All right, now this is a quick, short and sweet related rate problem. So let's identify all these numbers and the shape that we're working with. It says at the moment, the rectangle, okay, that's huge. The rectangle is 8 feet long. Okay, that long tells us what number or what that number represents. 3 feet wide. Its length is increasing. Now that's huge. Increasing, that means we have a rate right here. The length is increasing. Length is increasing 0.5. And its width is decreasing. That means this is a negative rate right here. So let's write all this stuff out. We got L equals 8. W equals 3. So length is 8. Width is 3. The length is changing. That's dl over dt at, was that 0.5? Yeah, 0.5. So I like using a fraction. So I'm going to write fraction. And then the width is changing negatively because it says decreasing at 1.5, which is the same as 3 over 2. And then I have the units, but I don't have the units until, I have to worry about the units until I'm finished with this problem. We have one variable, which is the area, and another variable, which is dA over dt. And I know that the dA over dt and the a are in here because it says the area. And then after where it says the area, it describes what the area is doing, how the area is changing. It doesn't care about what the area is. It cares about what this guy is. So I don't care about that. So we need our equation that relates these rates. And the equation would be A equals length times width. How do I know? Because the area of a rectangle is length times width. And so we're going to take the derivative of this with respect to time. We take the derivative of A, we get 1, so we get dA over dt. Make sure you guys do these problems before you see me do it, because otherwise you don't get as much practice. Now, I did probably the hardest part of this problem just now, and that was identifying all the parts to the problem so that we can solve it. Now, sorry, I jabber there. We have L times W, so we need to take the derivative of those, and since they're multiplying, we have to do the product rule. So we take the derivative of the first one, which is 1. You have dL over dt. Then we have to multiply that times W, plus, now we have L times the derivative of the second. So that would be 1, which I don't need to write. So dW over dt. I don't need to have that other one. I just wrote it because, teaching and stuff. Okay. All right, so now to find dA over dt, I got to plug in all of those other numbers that I know, and we already wrote them all out. So for the dL dt, we're going to plug in 1/2. For the W, we're going to plug in 3. For the L, we're going to plug in 8. And for the W dt, we're going to plug in, I didn't write negative on that guy. I remember who was supposed to be decreasing, so it's negative 3 over 2. And I have to multiply. Okay, so for the first one, we get 3 over 2. Then we have a plus, and then we get 8 times this. So the 8 is going to simplify with that 2. So I just have negative 3 times 4, which is negative 12. And since we're adding a fraction to this, let's make this into a fraction as well. So that's going to be a 2 on the bottom, which would make the top a negative 24. And so we add the numerators. We get negative 21 over 2. And I'm checking to see if we have that anywhere. Oh, it looks like they have decimals. So let's go ahead and make this into an improper or a mixed number. So it would be negative 10 and 1/2. That's the same as negative 10.5, and we're decreasing. So this guy's out. This guy is out. Here we go. That's our answer, letter A. All right, for number 18, again, we have a little mini related rate problem. So it's important to identify all of our numbers. So here we have our equation. That's cool, so we don't have to find an equation later. A particle is traveling on this curve. At the moment when the particle is at this point, that's cool. So that gives us an X. It gives us a Y. Its X coordinate, okay, that's huge, is increasing. That's big too. 5. So that means dx over dt. We always go over dt when we're dealing with related rate problems. You can tell too because the units say units per minute. And minute is time, which means we would have to have a dt on the bottom. It is changing at 5 units per minute. I just want to make sure that 5 is positive, and yes it is because it says increasing. So at this moment, what is the y coordinate doing? Looks like we're looking for another rate because all these say decreasing and increasing. So it looks like we're looking for dy over dt. That's our quest. So let's take our equation up there, which is x squared minus xy plus y squared equals 7. We're going to take the derivative of this with respect to time. We get 2x times dx over dt. And then we have minus, and we're going to have to do a product rule right here. So I want to use parentheses. I take the derivative of the x, we get 1. So just dx over dt times y plus, then we have the x times the derivative of y, which is just going to be 1 dy over dt. Close parenthesis. Now I got to take the derivative of this guy. That's going to be 2y dy over dt equals the derivative of 7. For some reason, a common mistake is always to forget to take the derivative of the other side. I know I've done it before. And there you have it. So now what we have to do is we can either solve for dy over dt right now and then plug in our x and our y and the dx over dt. Or we could just plug in everything and then solve, which is what I'm going to do. So first let's plug in this y right here, or this x, which is 2. Dx over dt is 5. I'll put parentheses around those guys. And then I have a dx dt right here, which is 5. We know what this y is, that's 3. Then we have that x, which is 2. This guy is what we're looking for. We have a y right here. No, yeah, dy dt. And we have a y right here, which is 3. And then again, we're looking for that guy. So let's simplify what we got here. We have a 2 times 2 times 5. That's 2 times 2 times 5. That's going to be 20. So we have 20 minus, and then that's going to be 15. 5 times 3 is 15. And then we have a 2 dy dt. And on the outside here, we have a 6 dy dt. Let's get rid of these parentheses over here by saying that's a negative 15 and a negative 2 dy dt. On the other side, we have 0. So we're trying to isolate dy dt. We don't need these parentheses anymore. That's a negative 15. Negative 15 and 20, those combine together to give me a 5. Now I'm going to combine our dy dt's right here. We have negative 2 and 6, so that makes 4. So I'm going to go 4 dy dt. I'm going to move the 5 to the other side, so we get 4 dy dt equals negative 5. Now I'm going to divide both sides by 4. Dy dt equals negative 5 over 4. And that should be our answer. Oh, they did decimals again. So this is going to be negative 1 and 1/4. So that's 0.25. Negative 1, or decreasing. So it throws up the increasing ones. That means we got to have A as our answer. Oh, this one's funny. It came up again. I thought we were done with this guy. So this is the definition of a derivative, which means we're taking the derivative of a function. Here you go. Here's a definition of derivative. It says, at this point, at this x value, if you take the limit as x approaches a of this slope, which is x minus a, and then on the top we have f of x minus f of a, that'll give you the derivative. And so we have to first identify our f of x. Let's identify our a. That'll really help. So our f of x is this guy right here. So that's going to be just simply that. The one with the x approaching a is always easier than the h approaching 0. We have natural log of x. And then our a is just a. And it didn't give us anything there. So we're going to plug in a. So first we got to find f prime. Then we're going to plug in a. We don't know the value for a. F prime is just going to be 1 over x. And if I plug in a, that's going to be 1 over a. So we got this. That's our answer. For our last problem, you got to remember when you see the negative 1 on a function like that, that means inverse. And that little prime right there means we want to find the the derivative of the inverse. Now, really quick, this should be a formula that you should just be able to regurgitate. If we had f and g, let's say we have f and g was our inverse function. If that was the case, then g prime would equal 1 over f prime of g. So we just got to plug the g in. But we're writing this as y to the, I'm sorry, f to the negative 1. I'm gonna not write it that way. Let's just write g prime of x. And we'll say that g is f to the negative 1. All right. So we don't know what the inverse is of this right off the bat. But we do know how to find f prime. We just need to know how to find g. Okay. So first let's find f prime. To do f prime, we have a function inside of a function. The outside function is the e to the x. I'll just write it right here, e to the x. And the inside function is 3x. So the derivative of the outside function is just e to the x. So we get e to the 3x. Then we have to multiply this by the derivative of the inside function. And the derivative of 3x is just 3. So our answer is 3 to the 3x. So that means g prime of x is going to equal 1 over 3 e to the 3x. But inside x, we have the g function. All right, so we got to find that g function. So I'm going to change that f of x into a y. I'm sorry, I'm going totally old school algebra right here. I'm just going to switch the x and the y and solve for y. And that will be my inverse function. So to solve for the y, we got to first natural log both sides. Because if we natural log an e, that gets rid of the e, because they're inverse functions of each other. So that means natural log of x equals 3y. And then if I wanted to get the y alone, I would have to divide both sides by 3. So that y, or this, what we just found, is g. So now we have g. G equals natural log of x divided by 3. So we plug that in. So what do we get? We get 1 over 3 e to the 3 natural log, whoa, it's really small right here, natural log of x divided by 3. Oh, cool, look, and these 3's cancel each other out. So now we have 1 over 3 e to the natural log of x. Well, a base e and a natural log cancel each other out because they're inverses, and then this x gets dropped down. So now we have 1 over 3x. Wow. If you were lost with logarithms back in pre-calculus or in Algebra 2 trig or Honors Algebra 2 trig, this problem would have been really difficult for you. Let's see if our answer's over there. Yes, it is. Cool, I didn't do anything wrong.